Hello and welcome to Unit 7. In the previous chapter, we learned how to decide what variables we're going to include in our model. In this chapter, we're going to be looking at what specification we're going to choose for our model, specifically the functional form. So far, we have only covered models that are linear in nature. For instance, this is a linear model. We know it's linear because it's linear in the parameters and the dependent and independent variables are not raised to any power. We also know how to interpret these kind of models. We know how to interpret the marginal effect of x1 on y. We're going to expand the amount of models available to us by including the so-called logarithmic models. In the logarithmic models, we're going to have our dependent and our independent variables, either one at a time or both, to be in logarithms. Economists really like these models because they relate a percentage change to a unit change or a percentage change to a percentage change. You might remember percentage change to percentage change in your microeconomics classes. They had to do with elasticity. And elasticities is pretty much the way economists talk to each other. So we're going to be seeing these kind of models too, and we're going to have to learn how to interpret these kind of slopes. We're also going to be looking at some other polynomial models. Here the models are going to have independent variables that are going to be raised at some power. In this case, it's going to be raised to the power of 2, or in this case, it's going to be raised to the power of -1. That's why it's called an inverse model. What we're going to see is, why do we actually need to have this kind of nonlinear models? And how do we actually interpret the coefficients for these nonlinear models? Now, I'm going to show you some graphs. Don't worry about them right now in terms of understanding completely what they are. They're just examples of the kind of models we're going to be able to come up with. So if you recall from our linear model would be a straight line going positively sloped or a negative line. Now here notice how we're actually able to create a model that is curvilinear. We're going to be able to capture some kind of curvature in our data set. And our marginal effects are also going to be able to change. So no longer the marginal effect is going to be constant, like in a linear model, but the marginal effect is going to be allowed to change based on current values of x. This is the so-called double log model. I'll explain to you what this model is about in greater detail during the chapter. A semilog, same thing. It actually allows us to have different marginal effects based on current values of x1, and it allows us to capture a great variety of shapes in our data. Here's a polynomial model, a quadratic model. And as a quadratic model, it looks like a quadratic equation. It has a minimum or a maximum depending on the values of beta 1 and beta 0. In the second part of the chapter, we're going to be looking at dummy variables. These are variables that are categorical. For instance, gender. For instance, religion. For instance, region of the country a person is from. We don't actually assign numbers to those kind of variables. We assign simply symbols that represent one value or the other. The symbols that we usually choose for these kind of variables is 0 and 1. So we're going to be looking at intercept dummy variables that allow us to shift our regression equation up and down based on a specific characteristic. For instance, this could be number of years of education. This could be the age of an individual, and the dummy variable would capture gender, male and female. We're also going to be looking at the slope dummy variables. These are variables that are going to allow us to change not only the intercept of a regression equation, but also the slope of it. So we can actually prove that the response of the dependent variable y changes with the value of the dummy variable.